Hi there, and welcome to this series of videos to help you with your maths revision. So giving you time to look at a question, decide how you would start it, and then going through the answers. A daily dose of 3 questions, 1 pure, 1 stats, and 1 mechanics. So let's get started. Each video will show you a question, give you some tips by focusing on the keywords and drawing out how to approach that question, and then giving the answers. So here's today's pure question. So this is a partial fractions question. That's how we go from a single fraction to the partial fractions. We split it up, and what we do first is set it up with a and b over the two linear factors in the denominator, and then we go clear of fractions. So you can imagine timesing throughout by that denominator that's on the left, all of this. So it's 1 minus 4x and 2x plus 3. And if we do that throughout, then the whole equation remains equal because we're doing the same to each term. So you don't really need to write them all out, but I've just written them there to illustrate what's going to happen. We're going to go clear of fractions. It will cancel with everything on the left, and then what will happen, it will cancel with just the denominator it's got and leave that the a will be times by the 2x plus 3, and then the 2x plus 3 will cancel and b will get the 1 minus 4x. So you wouldn't need to really write that out. Your first line would be 21 minus 14x is equivalent to a into 2x plus 3, given it the denominator it's not got, plus b into 1 minus 4x. And then we would choose values of x to make these two brackets 0. So I'll start with the b one first and let x equal a quarter, because if we let that bracket there equal 0, then x will have to be equal to a quarter. Now feeding that in on the left into the 21 minus 14x, you're going to get 21 minus 14 quarters. Now because we've made the second term the bracket equal to 0, we're not going to have any b's, but when we feed x equals a quarter into here, you're going to get a times 2 quarters plus 3. So 21 as quarters is going to be 84 over 4 minus 14 quarters is equal to 2 quarters here is a half, and half plus 3, 3 and a half, so that's going to be 7 over 2a. 84 quarters minus 14 quarters is 70 quarters is equal to 7 over 2a, and then if we just cross multiply, you're going to get that a is equal to 5. Now if we do the same and let x equal minus 3 over 2, because then that will make this bracket equal 0. So on the left, feeding that in, we'll have 21, and then it'll be plus 14 times 3 over 2 is equivalent to our b, and 1 minus, or it'll be plus 4 times 3 over 2, because of x is minus 3 over 2 times this minus here is going to make a plus. So we can cancel here. We're going to get 21 plus another 21, that's 42, is equal to, here we can cancel this 2 with there. We're going to get 2 times 3 is 6, plus the 1 is 7. So 7b is equal to 42, so b is equal to 6. So we've found that a is 5 and b is 6, and then we just need to do the integration. So having a go at the integration now, we're going to be integrating between minus 1 and 0, and instead of f of x, we can now put f of x in as our partial fractions, which was 5 over the 1 minus 4x, because we just found that a was 5, plus 6 over the 2x plus 3. Now, whenever we've got just a linear term in the denominator, that's going to integrate to ln's. So this is going to be 5 times the ln of 1 minus 4x. And then you've got to think about what will happen when I differentiate. It will give me 5 over that denominator, but then I'll times by a minus 4. So I need to get rid of that. So that's going to go on the front. And then plus 6, the ln of 2x plus 3. And then again, I'm going to be dividing by 2 to get rid of that 2 that will come from the chain rule. So I've integrated into my big square brackets between minus 1 and 0. And then now I'm going to feed my limits in. So it's going to be minus 5 over 4. And then when x is 0, you're going to have the ln of 1. Well, that's just going to be 0. Plus 6 over 2 is 3, the ln of 3. And then feed in the lower limit, it's going to be minus 5 over 4. When x is minus 1, you're going to have 1 minus minus 4. So that's the ln of 5 plus 3, the ln. Now when x is minus 1, you're going to have minus 2 plus 3. Well, that's also going to be the ln of 1. So that's going to be 0. So we're going to have 0 plus 3, the ln of 3, which is the ln of 27, just using the log law and taking that up. And then this minus minus will give us plus, I'm going the big brackets again, 5 over 4, the ln of 5. And then we're going to have plus 3 times the ln of 1. ln of 1 is 0, so that's plus 0. So altogether, it's going to be the ln of 27 plus 5 over 4, the ln of 5. This is a hypothesis test question. We've got Hannah claiming that she can win a game of chess and the probability of her doing that is greater than 0.7. So that's telling us that the current state of play is that Hannah usually wins a game of chess at 0.7, but now she's claiming that it's greater than. So what is happening usually is the 0.7, and that forms our null hypothesis. Now she's played 40 games and she's won 33 of them. So we need to state our hypothesis and then test at the 5% level. So first of all, we need to set out what sort of distribution this is, and she either wins or she doesn't. So it's binomial, and we've got 40, and the probability of her winning is just going to be p. Then we're going to set out our null hypothesis with what is the current state of affairs. It's usually that it's 0.7. So your null hypothesis is always equal to whatever's currently going on. And then H1 is that her claim is it's bigger than 0.7. So because it's bigger and the wording of the question, this tells us we've got a one-tailed test. You always find that out from the wording of the question. So now we've set out our hypotheses, we can say that we're going to assume H0 is true. So if we do that, x will be binomially distributed with 40 and the 0.7. Now that means that we think if she plays 40 games, she's going to win 0.7 of them, which is 28 games. Now what's happened, which is going with our claim, she's won more of them, but is the probability of her winning 33 based on the fact that we think she's going to win 28, is that so far removed that it is below this significance level? So what we need to do is find the probability that x is going to be bigger or equal to the 33. Now your calculator or your tables in the statistical tables always work the other direction, less than. So you need to do 1 minus what you don't want, which is x being less than or equal to 32. And if you do that on your calculator, it's 1 minus 0.9447, which is equal to 0.0553. So that's telling us that the probability of her winning 33 games based on the fact that we think she's going to win 28 games, is quite small. It's 5.05. 5.53%, just putting that decimal as a percentage. Now you compare that with the cutoff level, which is the significance level, and we can see that this is above the significance level. So if that probability was smaller than the 5%, then we would say that because she's won so many, it's so far above what we were expecting, then what we were expecting must be wrong. But because 5.53 is greater than the 5%, then this doesn't give us enough evidence to reject H0. So we would be accepting H0 and evidence does not support Hannah's claim. So in a hypothesis testing, you get 2 marks for saying what are you going to accept and reject, and then putting it in the context of the question as well. This is a constant acceleration question, and we have the graph. When you've got constant acceleration, you're either going to be using your Suvat equations, or if you've got the graph or asked to draw the graph, go with that way of working. Because when we have the graph, it's the area under the curve or the graph that is the distance, and it's the slope of the graph that is the gradient. Now we're told that this car has constant acceleration of 2.4 until t is 5. So that's the first section of the graph, and the acceleration is given by the gradient, so the slope of that line there is going to be 2.4. Now we're trying to find in part 1 the greatest speed of the car. The speed is on the y-axis, and how fast it goes, the highest speed is how high that goes. So we're looking for that value on the y-axis. So we're going to make a triangle, and then we know that the gradient is 2.4. That's given in the question, and gradient is change in y over change in x, or rise over run. Now we don't know what the change in y is, but we do know that this distance horizontally is 5, and that's equal to 2.4. So the change in y must be 2.4 times 5, which comes out to be 12. So this vertical distance here is 12, and if we just add that onto the 18, we can see that the greatest speed is going to be 30, and what are the units? Meters per second. Part 2, calculate the value of t the instant the car begins to decelerate. Well, that is here, and we're looking for this t value here. Now the next thing we're told is that the car moves with constant velocity until it is 300 meters away from A, and A was the starting point. So this is giving us a distance, and it's telling us that when we have driven at the constant velocity until that point, that the distance is 300. So distance is calculated by the area under the graph, and we've got an area made out of this trapezium plus a rectangle. Now those two areas add to be 300 meters. So we need to calculate what they are, and then we'll be able to find the t there. So the first shape is a trapezium. There's the parallel sides. 5 is the distance between them, and we've got 18 and 30. So the formula for the area of a trapezium is half a plus b, where a and b are the parallel sides, and h is the distance between them. So filling that in, it's going to be 18 plus 30 times 5. Now if you do that, that comes out to be 120. So it's 120 meters for the first 5 seconds, and then the whole two distances together are 300. So if we do 300 take away 120, that gives us 180, which must be this rectangle. Now we know that this rectangle has the dimensions 30 high, but we don't know what this distance is here. So if we do 180 divided by 30, that will give us 6. So there's 6 more seconds that have gone where we've been travelling at our constant speed. So the t here must be the 5 plus the 6, and that's going to be 11 seconds. Now the last part, calculate the distance from A of the car when it is at rest. Well, it's at rest when it gets to 0 speed there. So all we need to do to find the distance is calculate this extra bit of distance, which is the triangle on the end. And the next bit of information it tells us is that the deceleration is 6. So we have got another gradient here. The acceleration is going to be 6, and we need to do another rise over run. So we know that the rise is 30, the change in y. We need to know what the change in x is in order for that gradient to be 6. So 30 divided by the change in x is equal to 6. So therefore the change in x must equal 5. So this bit here was 5, and then the area here is going to be half base times height, 5 times 30, which is going to be half 150, 75 meters. So that triangle is 75 meters. So the total distance we were from A is going to be the 300 plus the 75, which is 375 meters. Thanks so much for watching. Do check out the channel, like and subscribe, and keep an eye out for some more videos. I intend to make some more on the run up to the exams, hoping these are helping with your revision, and good luck with your exams. See you on the next one.